Hi everyone, welcome to our panel. Open standard and open source always win. We have got an all-star lineup for you today. We have Andrew Richards from Codeplay, Andrew Waffa from ARM, Ramesh from Broadcom, and our panel host, Eleanor from Imagination Technologies. Eleanor, I'll hand off to you now.
Thank you, Manoj. Hello, everyone, and thank you for joining us on today's panel. So, as Manoj said, I'm Eleanor Brash. I'm Senior Product Marketing Manager at Imagination, and I've been joined today on our panel by Andrew Waffa from ARM, Andrew Richards from Codeplay, and Ramesh from Broadcom. I will hand over to them in just a couple of seconds and let them introduce themselves properly. But first, I just thought I'd say that we do welcome Q&A in this panel. We've got some questions lined up to get the conversation started, but we also should have some time at the end to answer any questions that come in from you, our audience. So if you do want to ask a question to our panelists, just pop it into the Q&A widget anytime as we're going along, and we will get to it at the end of the session. And with that, let's start our full introduction. So let's go alphabetical order, because why not? So we'll start with Andrew Richards.
Hello, I'm Andrew. I'm the founder and CEO of Codeplay many years ago as a video game developer. And so I thought these amazing graphics processors could be used for other things. And so I started Codeplay to build tools to enable people to use graphics processors for other things. And a couple of years ago, we were acquired by Intel, but we're still out here pushing the open ecosystem.
Perfect. Thanks, Andrew. Over to you, Andy.
Thanks, Ellie. Hi, I'm Andy Waffa. I head up ARM's open source office, and I also look after a lot of our open source software engagements and relationships.
Excellent. And you, Ramesh?
Hi everyone, Ramesh Radhakrishnan. I am part of the engineering product team at Broadcom, specifically in VMware, where we build cloud, on-prem cloud infrastructure stacks for our customers. And prior to Broadcom, I spent 21 years at Dell, again in the server organization. And in terms of open source and open standards, I was involved with ML Commons, which runs MLPerf benchmark, as well as with the ARM standardization effort for servers.
Excellent.
Happy to be here.
Thank you, everyone. Thanks for the introductions. So our panel today is entitled Open Standards and Open Source Always Win. So I think we can start with just a very set the scene question. What is winning? And what is winning when it comes to the context of the UXL Foundation? Ramesh, would you like to be the first to give this a go?
Sure thing. I can kick it off. So when it comes to winning in open source, I think there are two parties involved here. So one is the community, which is very important. And then a lot of the folks in the community are people that actually work in companies. So when we're talking about winning, I think it involves both sides deriving value from these open source projects or open standards becoming successful. In the context of UXL, obviously, there's a lot of different things at play here. From the perspective of a hardware vendor or a software vendor, which deals and works with various different entities that produce hardware accelerators and different software stacks. I think winning here is kind of reducing the complexity for our end customers, and then being able to get maximum performance and value out of any technology that they would want to deploy without having to endure the complexity that comes with hardware diversification.
Andrew, Andy, anything to add to that?
Yeah, I think Ramesh kind of hit all the key points. One could say that winning is adoption. It's about whether somebody can create revenue from a product based on the open source or the open standards. I think for the most part, it is, for me at least, when open source wins is when there's a community that's able to gravitate around a specific technology or specific standard. There's multiple competing organizations that are participating and ensuring that it's an even playing field for all to participate in.
Yeah, so I'll jump in. I think the fundamental vision for UXL is to enable people to write software for accelerated computing. In the old days, people would have a little CPU chip, and then that would run all of the software. And over the last 30 or so years, that started to change, and that the CPU is a relatively smaller part of the system in terms of programmability, and then there's a whole lot of other stuff around the CPU that provides a lot of extra performance. And a lot of that has been about GPUs, but there's other kinds of accelerators, DSPs, AI chips, and things. All of that processing should be available to people. The challenge in the past has been, as a developer, you're forced to develop software that will run on, well, pretty much any CPU, right? I mean, various companies have done a really successful job of enabling software to run on a CPU, but on the rest of that chip or the system, there's been only programming models that let you run on one or other accelerator. And it's just unworkable, right? It's unaffordable for people to take the whole software ecosystem and then get all software accelerated on all accelerators and have innovation in the market and have people inventing new kinds of chips. So the great benefit of open source here and open standards here is it does enable people to write software once and then run on lots of different processors. That's what it's all about. I think one of the strengths of open source is it's really easy to integrate in with other technologies. It's much easier for somebody if they're designing their chip or they're designing their software, they're designing some device like a self-driving car or something. It's much easier for them to integrate open source into their system than it is closed source. They can just go off and do it. And I think that's the real benefit. I think it's happened in the past. I think it's often true that you can sustain one closed system within any ecosystem, but there's always been an open source competitor, and open source is sometimes the bigger in all of that because you're able to support innovation, and that's what we're about here.
Nice. So I feel like I've seen a couple of things come out of that. It's about boosting productivity, which in turn can help companies generate more revenue or lower costs, whichever way you want to look at it. It's about building up a good community. And I guess open source wins when you are able to consolidate a community around yourself. And it's about opening up, for UXL in particular, the computing ecosystem to more accelerators. Andrew, you made a point earlier that makes me wonder. So you were saying that open source makes it really easy for companies to integrate with the software. How do you find companies tend to work with open source and open standards? I mean, let's take a step back before we go into that. So is there a difference? What's the difference between open source and open standards? What's our definitions here?
So that's a good question, right? And I think it's important to understand the difference because in many ways UXL is both. But an open standard is a specification and it's an interface, and you can have closed source implementations of that interface on either side, right? So a nice, easy interface to understand is USB, right? USB is super successful. It's like a hardware interface. You have a USB socket in your laptop or your phone, and then you have a plug, and you can plug in a mouse or a keyboard from anywhere. And so you can plug in different USB devices to different other USB devices, and it works. But none of those devices are free. There's closed source implementations of USB. There's closed source, the stuff is, but it's an interface. So when we designed SYCL, so I was the chair of the SYCL working group when we designed that. We designed that as an open standard, and then lots of people can go off and implement it. We implemented it at CoPlay, and Intel did an implementation, and various academics and other organizations did implementations of that. But that's a spec. Open source is where you actually have the implementation of it. You can just go, and download open source things like Linux and run it on your computer. So the difference there is, you can get open source for free and you can modify it. So the great thing about Linux is you can modify it to get it to work on different systems. And the advantage of open specifications is people can just invent their own. So they can invent their own SYCL compiler and their own hardware and their own software. The advantage of open source is it can move really fast, whereas it's quite hard to move a specification. An interface specification is hard to move fast, whereas an open source project can actually move very fast. And because anyone can add to it, you can adapt to new people's needs really quickly.
Nice.
I think having a standard be open is also quite crucial for adoption. it lowers the barrier to entry. It lowers or it minimizes any hurdles that developers may want, those developers that want to access that standard to implement in their software. If it's not an open standard, it's a much harder step up to be able to access the specifications, understand all the details, be able to actually communicate with others that are working on those specifications, to ask questions, to challenge, to submit potential changes. After doing an implementation, you may realize, actually, if the specification would actually go in this direction, it would make things easier for myself or whatever. Being an open specification works so much better. There are a number of open specs out there. Look at people like W3C for the web. If the specification wasn't open, I don't think the web would be as successful as it is now. And so I think having, UXL is unique in having an open specification as well as an open source implementation of that specification. And so we can work hand in hand. We can be kind of rather focused, or somebody can take that specification and do their own implementation. They can add their changes to the code base. And it just makes it a much more vibrant and healthier ecosystem.
Anything to add, Ramesh, to that?
No, I think it was covered really well. I would just add that with open standards and open specification, there's a more structured, typically there's a more structured approach as well, and probably that's why it takes some time to move it forward. With open source, once you have a project and it's out in the wild, again, it depends on how it's governed and who is actually in charge of accepting some of the the PRs and committing them. But yeah, I think both have a place, and in some cases there's overlap when it comes to industry. Open standards obviously provide an option, and in our case, when we're talking about accelerated compute, there is a demand in the industry for openness and being able to leverage different technologies from different vendors, and sometimes it is harder to provide that when there is a very successful approach in the industry and a commercial approach that is well established. So I think doing it using open standards and leveraging open source is kind of the way to transform the industry.
So I'm going to apologize. I recognize Andrew is flitting in and out. We will try to rescue him. But meanwhile, I can work with Andy and Ramesh to address, I think, where my next question was going based on one of Andrew's comments about open source being easy to integrate into their own technologies. So I guess my question is, Andy, you work at ARM. Ramesh, you work at Broadcom. You probably have examples from your experience elsewhere. But how do companies tend to work with open standard and open source organizations? And how do they go about adopting them into their own solutions?
Ramesh, do you want to go first?
Sure. I think it's going to be different even within each company, depending on what products and where they're using it. It's obviously being used at multiple places. So like for a company, companies that I worked in, we've used it in our development flow. And there's, libraries and utilities that are open source that are being used. And then there's also use in, strategic manner where it may be a core part of a big product itself. So I think it varies on how it's actually being leveraged. But the key part is that I think there has to be demonstrable value in how it's being implemented and leveraged inside the company. So obviously, and when I'm saying values, I'm talking about employees that are contributing back to open source as well for those specific projects. It's easy for people to leverage open source and just use it, but obviously, if you're contributing back, giving back to the community and participating as part of that open source project, then there needs to be value that has to be proven out to the employee, because this is the employer's time that's being spent here. The value is not just in it being leveraged, but also how it adds value and provides ROI back to the employer in this case. Andrew, anything else to add there?
Well, there's two Andrews. Yeah, see, we're getting confused.
Yes.
I'm doing Andy and Andrew.
Yes. Do you think?
I think, it's for us, one of the big values of open source is lowering the maintenance cost. by collaborating out in the open, by having open source as that force multiplier, we're able to minimize technical debt, we're able to innovate faster, be more responsive to requests of our customers and of the business. And so for us, certainly from a software engineering perspective, open source is kind of the primary way to go. And, from an open standards perspective, we want to engage as best as we can in open standards. There are times when we will choose not to go down the open standards route initially. That's generally speaking more of a understanding the lay of the land and how things work out, and then making sure that there's no impact to the business. And generally speaking, most of the time there isn't. And so participating in the open standards makes perfect sense. And so, it's very much making sure that we are able to lower our costs, both from an engineering time perspective, but also from, that ultimate bottom line dollar cost to the business. And it enables us to be much more flexible and agile.
Yeah, so I think these are all interesting points, but I think it's a really good switch to the question that's been asked here, which is kind of about some of this stuff. I can see one in the Q&A. So talking about 1MKL. So I've been quite involved in this because 1MKL is a really good example of where some of these things cross over. 1MKL is a mathematics library that has a long pedigree at Intel as the MKL library, and then there's a kind of open standard version of it. And there's kind of two different aspects of 1MKL. So one is there's a specification, and you'll see the specification as part of the UXL Foundation specification. But the other is you'll start to see some open source implementations. I think it's not 100% open source, but some open source implementations. So why is there both there? It's for good reasons. So if a chip vendor like Intel or ARM were to do optimized versions for their processor, they'll end up doing it like super optimized for their processor. And as a developer, you might want that, but it's not necessarily that useful to have open source because it's like super optimized hand-coded assembly by all sorts of wizards that do amazing stuff and lots of complicated stuff in order to get the maximum performance on one processor. And there's quite a lot of features in 1MKL that you might want. So I think that where we're going to end up with this is that we will have an open source implementation of 1MKL, probably using the SYCL language so that it fits in with things, or maybe using some of the existing open source libraries that do all of the things that are in 1MKL. But you'll probably, if you want the best performance, you're probably going to want your chip vendor to provide a really, really hand-optimized version of some or all of those libraries. So as a developer, you might want open source so that all of 1MKL works on every bit of hardware, and we'll write it in a generic way. That's what we've been doing so far, write it in a generic way so it works everywhere. But then you probably do want, that secret source hand optimization for each chip. That's where I think it's going to go.
Yeah, I mean, by having an open standard and having multiple implementations of an open standard, it does allow for that fine-tuning, but also it allows for portability. And I think having code portability in the modern heterogeneous compute space is invaluable. Whether it's multiple compute platforms on a single system, CPU, GPU, NPU, etc., or whether it's multiple operating systems, multiple clouds, or cloud plus on-prem, etc. I think having an open standard that has multiple implementations is absolutely fine. And I think having different implementations is not necessarily a bad thing as long as it adheres to the standards.
So the question is, how do we test it? That's the other thing that we've been focusing on is testing within the system, so that we test so that people are providing a full implementation of all of the features, as well as letting them do a lot of extreme optimizations for their hardware.
So I think one of the things you touched on there, Andrew, leads into a subsequent question I had, which was about how companies innovate on and with open source standards. Where is it if open source and open standards are winning? where is it that companies can add their secret sauce, their fairy dust, and how does that go about working?
That's a good question, because often people worry about it and it's not always obvious. So the SYCL standard, which is the C++ programming model that underpins one API in UXL, is a Chronos standard, and that requires a minimum feature set. So Chronos standards say, here is a minimum feature set, you must support all of this. So that means as a developer, if you use that minimum feature set, it should work on any conformance implementation. And Chronos provides rules about how you test for that. But it is a minimum. You are allowed to add your own extensions. So, for example, if you are a chip company and you go, I've got a special feature of my chip, you can add that to the SYCL standard. You can document it. It's your IP. And the developer can look at it and go, well, do I want to use this special feature? They may well say, yeah, it's a great feature. I'll use it, but I'll only use it when running on this hardware. And SYCL actually makes it quite easy to only use one feature on one piece of hardware and not use it on hardware that doesn't. So SYCL is not a maximum, it's a minimum. With UXL, it's a little bit different because we are an open source project. And so you can open a pull request and say, here's a new feature. You can add it. But of course, then it's available to everyone. But the licenses we use for UXL actually allow you to add your own closed source features. So, for example, you could say, this chip, I have this actual implementation, or you might want to build a debugger, which is not necessarily part of the spec. And you can build a debugger. It can be closed source. You don't have to give it away. So the question you can ask is, do you want developer adoption for it? It's so easy to get developer adoption. But you might say, no, this is my special feature. I want to keep that closed and my own. And then I'll add that on top. And then people have to pay money for it. But we allow all of those things. I think the main thing that we've got to get to is we've got to be able to really sort use the minimum, we promise to support this everywhere, and then it's safely built on top. And then you get extra features. That's what we've got to get to.
Interesting. Ramesh, anything to add to that from Broadcom's perspective?
No, I think that's the right approach to take, because especially when it comes to hardware vendors, there's going to be different implementations and optimizations that is their own IP. And then if you are trying to force fit and have a base specification that doesn't allow these innovative features to be showcased, then people will gravitate towards a different stack that provides the best performance for them, which leverages that feature. So yeah, I think it is important to be able to provide these, to have an approach that'll help companies add their own secret sauce and enable this, but in a manner that still provides flexibility and enables the developers to choose and have the option of whether they take advantage of it or not.
Nice. Andy?
Yeah, I think building on open source allows people to provide very specific value add in areas that they specialize in, and especially if it's something built on standard. Generally speaking, that core layer, that area of commonality, especially when it comes to portable software, there's not a huge amount of value to be added there. It's common across all the platforms, across all the vendors, etc. And so by working to a common standard and being based on open source, it allows people to provide dedicated and specific value to areas that they are far better, more knowledgeable in. For instance, with regards to graphics or networking or any other accelerator, they can add their value on that dedicated piece of IP. All the supporting software is going to work because everyone's got the same problem. And so by collaborating on that common problem space, it just makes things easier for people to add the value to the areas that count for them.
When I was a video game developer many years ago, we'd build everything from scratch. We'd build the whole all our own game engine, all the tools, everything. As the software got more complicated, you just can't do that. You can't build everything from scratch anymore. So yeah, you do have to be able to take the components and go, I will add the key value that I'm good at and not to all the stuff I'm bad at as well.
Where then are the challenges? if open source, open standards are amazing for lowering developing costs, introducing standards across the software community, increasing openness, allowing companies to focus on their specific areas of differentiation, where's the bad point? I mean, Andrew, you touched on testing earlier. I don't know if that's going to come up here or if there's anything else that open source and open standards find tricky and wouldn't win at.
I do think we are going to have to get on top of the testing and be strict about it so that you can rely on UXL on different platforms. We're building the testing now. As people port it to their platforms, we're gonna have to deal with the fact that there's a lot of failures on new platforms as it gets up and running. But we're gonna have to get stricter on the testing at some point so that people can be reassured that the whole system works on every hardware.
I think your question earlier as to where's the downsides to open source, etc. As with a commercial hat on, the trick is how do you make it sticky to your respective company, right? If it's all common and whatnot, then why should we buy software from customer A versus company A versus company B kind of thing? I think in UXL's perspective, that actually works to our advantage because a lot of the people that are going to be leveraging UXL aren't necessarily building a software revenue stream around UXL directly. UXL is not just an accelerator framework, but it's an accelerator to enable you to generate revenue. Most of the members are doing hardware-related things, whether it be from different chip-related aspects, at Intel, at ARM, at Broadcom, etc., or whether it be automotive vendors like Mercedes or whomever, where they've got multiple hardware components working together and they need it to all talk to each other as quickly as possible and get the ones and zeros from one end to another and whatnot. So for them, it works fine. But generally, from an open source perspective, the trick is how do you make it sticky to your company? And I think that's the biggest hurdle. However, from a UXL perspective, I think we're able to negate a lot of that requirement due to the nature.
Ramesh, any thoughts on this?
Yeah, I'll bring up a couple of points that weren't mentioned. So one is, there's the open source project itself and the value that it adds. And then if you look at other open source projects that are successful, like Linux, for example, right? There are other companies in that ecosystem that participate and then provide a commercial offering as well with support, right? So I think it's important that there is momentum that grows for this and the ecosystem grows so it encompasses every player that is a part of this ecosystem and everyone is participating in this and adding value to it. Otherwise, you're going to have other options that are available for the end user that may end up being more attractive from again, depending on their point of view and how they prioritize some of the value adds that they are looking to see for the software stack. So I think that is critical. And then, again, kind of talking about ecosystem, there's a lot of other tools, right? When you're talking about things like performance profiling tools and other tools that are used. I think it's important that we have, again, these may or may not be open source, but it kind of becomes part of the overall stack. And so I think that has to be thought out. So it goes beyond kind of the core project, and then there has to be a wider perspective on how everything else plays. So it becomes challenging from that perspective, but it's very important for the success of the project itself, or at least the commercial success of the project.
I think the point everyone's making is that we've got to think about not just the technical needs of everyone and all the technology and stuff. We've got to think about the business needs of everyone so that to make a community in which people actually contribute and make this a lively community project. I think that's what I think that's kind of what we're all saying is like, how do we think about what do people need to get out of this so that we get them to actually put the maximum into the project. And the picture for me, for hardware vendors is, look, you're going to get all this software running on your hardware, right? So you're going to be able to sell your hardware. And the picture for software developers is, look, you're going to be able to run your software on all these amazing new processors that can achieve lower costs or greater efficiency or higher performance or some new experience that you're just not able to do today. I think we should be clear about those benefits to people, and then say, right, you need to put in a bit of effort to make it work. I think you're also highlighting that tools vendors, and CodePlay was a tools vendor, independent tools vendor for many, many years. So I'm acutely aware of the difficulty of making money out of software tools in a world where software tools are free and open source. But, selling commercial support, for example, actually supporting open source software so it's reliable and certified on different platforms. I think there are opportunities there, and there are opportunities for people to add their own special secret sauce that's unique to them that they sell on top.
Yeah, so I guess it comes back to one of the points we had at the beginning of what is winning when it comes to open source. And in many ways, it's getting the community that's using it big enough that you can win. It's getting enough people contributing into it that it's universal enough that it works across enough products and situations. I guess, how do different markets, this might turn into a one API specific question, I guess. How are different markets working with one API? It scales from the cloud down to edge devices. Is there a difference in the way people are using it, in the value people are seeing in it?
I don't think the difference is as big as one would think. Whether it be in the cloud and data center, at the edge, kind of in the telco space or smaller. I don't think the usage is that different across those different verticals. I think the difference really comes down to the type of interfaces. So video interfaces moreover versus pure CPU interfaces over GPU, etc. I think that's where the differences are going to happen. But if you're doing a video acceleration interface at the edge, the smart camera space, or if you're doing it larger scale, that's going to stay the same effectively. You're going to have more constrained resources, but for all intents and purposes, it's the same versus doing it on CPU. Yes, having larger CPU count on a cloud instance versus on an edge device, you're going to be able to do things quicker or more data, etc. But the implementation's the same.
Yeah, so I think what we're seeing with one API at the moment is the kind of adoption curve of new technologies, which is of starting at the high end. So we've seen a lot of it in supercomputing and HPC. Like we have a lot of software that's been ported to one API in supercomputing and high performance computing, and you can get lots of data on that. And that's because they will adopt the latest technologies in order to get the latest performance. But they will also give you a lot of information. They'll do lots of papers. They'll describe how to do it. They'll produce more open source software themselves, and so they're a big contributor to the early parts of the market. We're seeing a lot of work now go along in data center AI as one API is being upstreamed into PyTorch, and that's a process that's happening, but we'll start to see more and more progress of that. So that's going to drive you into new markets. I think Andy highlighted both a weakness of where we are today and also a strength in talking about video interfaces, and that's true of all the edge stuff. Is like, how do you interface to this? How do you interface to that? Now, in many ways, open source has got a great answer to that, which is it's open source. You can add the interface, and we're using open standards, so you can add interfaces and stuff. But at the same time, we don't have that really in one API today, and we need to add it. So that'd be a great thing for you to add. Because you don't have a video interface on a supercomputer, right? You don't plug a supercomputer into a camera. You don't plug a lot of data center AI systems into a camera, that you might plug it into, a video decoder or something, but you don't plug those systems into cameras. But it's normal to go to very large systems that definitely won't fit into your pocket, all the way down to those lower power systems, and we're doing it pretty rapidly. I always used to say when I was a video game developer, we'd take ancient technology that had been through decades of other use from supercomputers all the way down, and then suddenly we were at the point where our GPUs were more powerful than anything else. So the gap between edge and supercomputing is a lot shorter than it used to be.
I think one way to look at it is kind of if we dissect it or represent this in an X and Y axis. So there's this scale going from edge to HPC clusters or AI clusters that can be, today thousands of servers or even more when it comes to building some of these AI models. And then in terms of where the developer is actually spending their time, so it could be at low-level code. Like in HPC, you have to go fiddle with the actual kernels and actually write code there to get the result that you want. Whereas a AI developer today is focused on Python, and the abstraction goes higher up in the software stack. So I think from one API perspective, it has to play in both spaces and provide solutions to both of these approaches, right? So as we see these higher level abstractions and tools kind of becoming the norm and hiding the actual implementation details from the end, from the developer, it doesn't mean that the one API work is actually not being exposed, but there's work being done by the different hardware vendors to provide those optimized libraries and optimized kernels that are being exposed to these higher level abstractions. But again, I agree with Andy and Andrew about from the edge to the large scale supercomputing space, there's a lot of commonality there these days because it's just the scale at which it's happening.
Yeah, I think that the only exception to my examples would be something like automotive, where you have a large number of interfaces all requiring acceleration in one shape or another. And so that multiplying the complexity of this.
Nice. So we've just got a couple of minutes left now in this panel discussion. We are getting very close to the end. If anybody does have any questions they'd like to ask our panelists, do pop it into the Q&A widget now. Meanwhile, I've got a couple of final questions to see us through the last couple of minutes whilst people are thinking of questions to ask. And one of them is about the interdependencies between different standards organizations and how that is managed. So I think we've mentioned Chronos and the SYCL standard as something that's very handy to one API. How do you work across different standards organizations to make sure it all works beautifully together?
Yeah, so that's a good question because every organization has slightly different rules about how it communicates. So Chronos has quite strict IP rules that have created some challenges in some ways, but in other ways, the standard is already there. So you'll see that there's been a complexity in that we don't have and won't have the compiler, the DPC++ compiler within the UXL Foundation repositories, even though it's critical to what we do, because we're going to upstream it to Clang and LLVM. That's the plan, and that's the most sensible thing to do. So it's an example of how we're collaborating with the Clang LLVM project under the LLVM Foundation. With PyTorch, that again, we're upstreaming it to the PyTorch project. That's another Linux Foundation project, and it's open source. So in many ways, actually, it's good that we can collaborate in these ways. And I think what we've got to do is we've got to mimic some of the processes that these organizations follow. That's what you're seeing us do now. We're creating all of the open source community projects and processes to make us mimic those organizations and work with them. We're doing it with AutoWare as well, aren't we? There's actually a lot of advantages of open source that you can create these open collaborations.
Nice. Andy, any thoughts on that? I think you're working a little bit on the AutoWare project as well.
Yes. Yeah, no, we are. And I think they are somewhat complementary. And by, as Andrew said, by trying to push as much into the relevant open source projects, it simplifies things for UXL. It lowers the burden on adoption of UXL, etc. So I think that's probably the best route we can take to try and minimize any of that conflict and overlap.
There's a good question in the chat.
There is. Do you want to address it?
As an Intel employee, yeah. So the question is, one API is very attached to Intel, and two examples are given. One is one MKL, and the other is one TBB. So slightly different answers for each of those. So I agree that we have to disentangle. Part of this project is to disentangle one API from Intel, even though Intel put in a huge contribution here, huge amount of work, and provided that to the community. We do need to disentangle it. So I think we're going to end up with the one MKL project being actually restructured a bit This is an open RFC, so I won't say what the final answer is, but it's open RFC. You can go and have a look. I think we will disentangle MKL from one MKL, but in the spirit of the community, well, the community will have some say, have the final say in how that works. But I think we will fix that. It's something I wanted to fix. TBB is interesting because TBB is also another open source Intel project. So you would think that people only use it on Intel CPUs. And I can tell you from speaking to lots of people, it's used on lots of people's CPUs. It's actually very widely used outside the Intel world. And the trademark license thing, yes, I suspect that ownership of that has to get disentangled. I was talking earlier about, compliance, and we have to define compliance, but I think that the community has to define what compliance means, because I think it is going to be a little bit complicated to work out what compliance means for a supercomputer versus an edge device. But I think we have to work through all of those issues. But we work through them as a community.
I am going to apologise to all our audience for running a little bit late, but I will ask the last question that is on my list, which is, how can people get involved in the UXL Foundation?
Become a member, submit pull requests, turn up to the calls. I don't think you even need to be a member to turn up to the calls or to submit pull requests, but you can do all of those things or none of those things. But please do. It really is a community project. We really do want your contributions. If it's a little bit difficult now to get contributions in, we are absolutely working to fix that, and you can help by getting involved. It's definitely a community project. We're really motivated to make it work.
Nice. Okay, I apologise to everyone for running over, but thank you very much to Andy, Andrew, and Ramesh for joining me today on this panel.